we're going to go through lighting and rendering and a little bit of materials. So those of you that are new to 3D, so far we've been modeling out of this kind of virtual clay. But to make this look, like an awesome 3D scene, the next steps is to light things. And then what's called rendering is when we let the math take over and generate an image for us, whether we're rendering a single frame or rendering a sequence of frames that we then turn into an animation. So we're going to create a little render box and just try a whole bunch of different settings. I'm going to introduce you to Maya's default renderer, or software renderer, which doesn't give you as cool effects, but it's lightning fast, and just depending on what you're trying to do, sometimes that's the better solution. And then after that, I'll show you their high-end industry, heavily used Arnold renderer, which is just really, really cool. It can give us some stunning results pretty quickly out of the box, and we can start to make this clay you've been working with come to life. So first step, like anything else, if you have a scene open, be sure to save it, iterate it if you need. We're going to open a new scene together, and before we even worry about the scene, we worry about our project. So I'm going to take a peek at my project window, and I'm going to create a new one. I'm just clicking new here, and maybe I'll call it in class. Sure. I will keep that. I'll stick this on my desktop. Now I'm going to save my scene. I like to just organize my project and scenes and everything before I even start working. So I'm going to save my scene as, I can go to new scene first if you've got anything open. And then save my scene as, and it automatically goes inside of that scenes folder in the in-class project. And I'm going to name this basic lighting. In fact, maybe I'll put an underscore here. There we go. Leave it Maya binary as file. Some people like to save Maya ASCII because you can actually get into the text file and make manual edits, but Maya binary is the default. Just leave it like that. Student version, and we're ready to go. So the first thing we want to do, we're going to model a little scene here. Render box, as it's called. So the first thing we're going to do is let's go to create polygon primitives, and let's check the options next to cube here. All right, so sometimes I just draw it right away and then change these options in the attribute editor. Sometimes I know exactly what I want ahead of time. So let's make a 10 by 10 by 10 cube. We got 10 Maya units, and then let's make the divisions only 1. This is going to be a room that we're going to be inside of, so we don't need any real mesh detail. We just need the size to it. So choose that, hit create. Now we've got our cube here. All right, and we want to get into, I have the outliner open. That's a good idea to always have open when you're getting started because it helps you manage and organize your scene. As you can see, there were 6 objects in the scene by default. Organizing and managing things, keeping track, naming, this stuff is very, very important in 3D because things can just get so complex. The more organized you are, the more time you're going to save yourself. So I'm going to double click this and maybe just name it room instead of pcube1. All right, so now I've got this cube named room. You can see over in the attribute editor, it renames a couple of the nodes, leaves this polycube node that's got its original stuff in there. And then it's got a default light set and a default object set. All right, so we've got our room. Now let's go ahead and right click and choose face. You could use the modeling toolkit and choose face, but I typically use the right click menu when I'm dealing with components like this. Let's choose this front face and delete it so we get this empty box with a face in it that we can go into. All right. So now after the empty box, now we want to draw or create a couple primitives. I'm going to go back to the poly modeling. I just want some 1 by 1 primitives, so they're only 1 unit inside of this 10 unit thing. I think that's going to be the default on a couple of these. I'm going to hit my sphere, so definitely start with a sphere. I'm going to check it out. Yeah, it's got a radius of 1. Keep the same density, the subdivision 20, which is enough to have it be spherical and see some stuff going on. So we've got this sphere. And then we're going to want to draw, let's say, another cube. I'm pretty sure if I hit the cube, it's just going to draw another 10 by 10 box. So I'm going to undo that. And let's say I'm going to double click the cube icon. So that opens this. The exact same thing is going to create polygon primitives cube, and going to here, you just double click that icon, get the options to come up. So I want my cube also to be only 1 by 1, and I guess we'll give it some divisions. Let's swap this out and we'll give it 10 divisions. Create. And now they're right on top of each other. So I want to move them around a little bit. I'm going to take my sphere, move it kind of ahead of it a little. It's a little too much. I want to stay in the box. All right, now maybe I'll take my cube. In fact, this cube's looking a little small. Maybe we'll up this to 2. How big is that? Yeah, let's make our cube 2 units instead of 1. So you can just select it, go to the attribute editor, make sure you're on this polycube 2. We can leave these names, that's fine. P-sphere 1, P-cube 1. Just be aware that you can double click them to change the names and organize things. So now that we've got this, I'm going to move it kind of, the move tool up a little bit behind the sphere. All right, so it doesn't have to be exact, but just so they're a little bit apart and they've got a little bit of difference in their, in their position. So I got the sphere a little bit higher in front to the right. All right, we've got a cube sitting back here. Okay, so then finally now let's draw a torus. So that's a fancy 3D name for a donut shape. So we've got our donut shape. Pull this up, maybe I'll move it down a little, have that kind of under these down a little bit more. All right, so something about like that. I'm gonna hit save. All right, my basic lighting. And what this does is this gives us an environment to get a nice position inside of and see some walls and see the effects of shadows and reflections and all these different levels of rendering that we're going to step through as we start to add lights and see how different lights affect different things. Whoops. All right, so now the next thing, instead of just willy-nilly constantly moving around in our viewport like this, I think now's a good idea for us to create a camera. All right, so what I want you to do is go to a 4-up view. You can either click this icon over here that's a 4-up view, or if you just tap the space bar, that will switch your views between 4-up and one like this. You see that little menu come up. Again, if you hold space bar, you get like the super ghost menu. I don't remember the hotkey. You could look it up, or I'm sure there's options inside of Windows workspaces. I'm sure there's like an advanced super option where it just turns everything off with the viewport. And there's a lot of Maya artists who like to work that way, and they just get to all the commands through right-click, contextual right-click menus, using this ghost menu. And then also, if you have 2 monitors, you might have like a larger monitor or something to work with. If you start working in 3D a lot, it is extremely helpful to have 2 monitors because there's so many different windows with Maya to constantly be opening. It's really helpful to be able to put some of those on another screen, to be able to, just have just the viewport on one screen if you like. So it's very, very helpful when working in 3D on something like this to get yourself a second monitor to be able to connect to with your laptop if possible. But just for learning the techniques, not a big deal. But if you start spending all day in it, you'll save yourself a lot of time. All right, so I'm going to go down to the channel box instead of the attribute editor, which is a bit thinner. It still shows me my transforms here so I keep track if I'm trying to manually position, rotate, or scale something. But it gives me a little more room. So if I've got that here, I've got the outliner. On my HD screen, you guys may want to, even close this further if you wanted to give yourself a little room to see these viewports. So depending on the size of your laptop and whatnot, you may have to do a lot of moving around. So try and minimize that if possible. So anyway, from here now, we're going to create a camera. So we can just go to create cameras, and there's some different types of cameras. You can get into stereo cameras for, like 3D and all kinds of crazy stuff, but we're really just going to deal with a regular camera because the regular camera has a ton of options, and not only like 3D only options, but also real world options to like match it to like an actual camera tracking and all kinds of stuff. But for right now, we just tap the camera. You can see we get this little camera icon in the middle of our box. And we can move it around like any other object, and it does indeed. So what I want you to do is move it looking in these orthographic views, so I can see that I cut the side off of my box, not the front or the top. So I want to kind of position this, rotate it so it's in front of my box, and I can use the perspective to kind of see also, right? So it's in front of it. And then I want to rotate it so it's kind of facing in the box. All right, and now the key here is to be able to turn one of our viewports into the camera viewport. So what we're going to do is I'm going to take this side view. I don't really need this side view. I may want a top and a front view at some point. I don't really need this side view, and I'm just going to change it. Now, I want to leave the perspective open because I still want to be able to like manage my scene and look at things and zoom in and out without affecting my camera. All right, but now to actually place the camera we want, we can look through it. And under panels, we now have our camera 1 that we added, and you can add camera 1, and now all of a sudden your viewport is looking through your camera. Now what's cool about this is, first of all, if I were to go to the perspective view, grab my camera and start moving it around, I sure like it just updates and you can see that it's actually being the camera's view. But what's cool about this is if I'm in the camera view, I just right clicked to get the viewport to take focus, which you can do without actually clicking in it. And then I can still use the Alt key to, you know, tumble and rotate and dolly the camera. And you can see that if you look at the camera over here, it's actually moving around. So when you do that in a camera view, you're actually moving the camera. You can see the transparency and the walls kind of come up a little bit. It's kind of funky when we just have the default light. But what I'd like you to do is basically just get your camera inside of a position where like about as close to inside of the box as you can without seeing any of these outside edges, right? So just go inside the box and then just give yourself a relatively interesting angle. So that works for me. I'm in the box. I can see, I'm not sure if I can see the floor. I guess I can see the floor a little bit down there, but I can see the ceiling. I can see probably a little of the floor. I can see a little bit of all of them. Just a nice, interesting angle. I'll go a little more like this so I can see a little more depth of that cube. There we go. That's probably good. So when we render this scene, we're going to be able to see things bouncing all over the place. All right. I'm going to hit save. And then once it's there, you know, you can take a peek at your other viewports, kind of see where it's at in your scene. But I'm going to select in my camera view and go back so the camera view is the main view. Save my scene. In any of the views at any point, you can do it just like this. You go to panels and then perspective, and then you can choose the camera you create. And that will automatically make that specific viewport your camera. So I usually do it with 4 up so I can actually see the camera and keep a perspective view, because there's a big difference with when you're just moving around the 3D scene and looking around to like zooming in and out, positioning things. You don't want to be moving your camera around typically. Typically your camera is set up in a very specific spot. And that's what we're getting at here is usually you're not going to be doing any rendering without having a camera set up. You're usually not going to be just rendering your perspective scene because you can move it and then lose it, right? And not get that right angle back. So it's always best to have cameras. Now, one thing that's interesting about a camera is as you are moving it around in the camera scene, actually moving the camera. So you can use the bracket keys, which are to the right of the P on the keyboard, to undo and redo camera movements. So right now I've got this view, and because I selected everything, which was actually pretty cool to be able to see, If I were to want to move this camera and I put it in a wonky position, I can use the back bracket and it snaps me back to the one I had before. So that's just a little trick to be aware of, that, you know, if you accidentally nudge your camera, or it's very common to think you're in a perspective view and you just want to go look at something real close and then realize, oh crap, I'm in my camera view and I just screwed up my camera position. You can use that little back thing, which it actually does it in the perspective view also, which is interesting. That's cool. I didn't really realize that. So you can use those as forward and back between kind of tumbling around. Get my camera position back to a good spot. Let's see, I think I'd rather see the floor than the ceiling. There we go. That'd be a good one. Okay, so when you're ready, just go back to object mode here. Deselect everything. Another reason to sometimes have multiple. I do go between 4 up and 1 up a lot. It's something that I think is worthwhile. It's tempting to just stay in the perspective view all the time, but sometimes it's helpful to see things from those orthographic sides. All right, so save your scene. You can see it says camera 1 down here. Now we're going to render the scene, which will turn it into an image with the default Maya renderer and the default Maya light, which isn't going to look too exciting, but I'll show you. It's kind of a progression that we're going to do here. And what we want to do is start off this little button up here. There's a global button that's always up here. This little, like, I forget what that's called, the little takes thing for a movie or whatever, a little icon. But the one with a little gear on it, that is your render globals, or your render settings. It used to be called render globals, now they call render settings. Open that up. And inside of your render settings, you've got this render using, and I believe it's defaulting to Arnold renderer. And for right now, you want to see there's 4 different renderers. There's a hardware renderer, a vector renderer, Arnold, and then the software renderer. Arnold is the badass beast that does awesome things, but takes a long time. The vector renderer, you can render out toon type stuff, and there's a lot of cool vector options, and it's extremely fast. The hardware renderer traditionally is meant for, you may not get quite as photorealistic results, but you may get damn close, and you can render straight from like your graphics card, basically in real time from your viewport. So it doesn't take any time for you to sit and wait for it to render. So some interesting things there, and we'll see if we can explore this a little later. But new in 2020, Arnold claims that it's got some pretty serious viewport rendering. Like you can get pretty close to the real thing without having to wait it out in the viewport. So that'll be interesting for us to check out. Arnold render times can get pretty wild depending on the quality that you're ramping up. And then on this common tab under the render settings, we're going to set up the Maya software renderer. All right, so choose that. And then you can hit close. We'll come back into the settings later when we actually want to save an image out. Right now, we just want to see what it looks like. Later on, we'll actually save images and sequences and stuff like that. So once you do that, then you have this icon over here that is render the current frame. All right, that's the one next to the little eyeball. The eyeball displays the rendered image, but we don't have one yet. So it's this one that's empty. There's one with an eyeball, one that's empty, one that says IPR, and then one that's got a little gear on it before we get to the sphere thing. The gear is the settings. The IPR, I'll show you that in a minute. We're going to do that a different way. Click this regular clear one, and you can see the amazingly flat gray rendering that shows up. All right, it opens this render view. It's giving me some kind of error at the bottom. It is an Arnold-related error. Well, we're not using Arnold, so we don't care about that. But you can see that the default light, without adding anything, is kind of coming down from the side. One of the walls isn't lit at all. It's as flat as possible. There's no shadows, there's no depth, there's no anything. But it renders an image. And the Maya software renderer has a default light in it, so you can at least see stuff. We'll see when we get to it that Arnold does not, and it can be confusing at first why things are just black. This is really important to understand how the basic lighting works, because it's so much faster, and there's a lot of situations where this may be all you need. All right, cool. So we've got this ugly scene. Let's make this way prettier. The first thing to do, now we're going to start by lighting things without any materials. All right, we're just going to keep it with this flat, basic clay matter, and then we're going to add some simple materials to it, and I'll start to show you, how that makes a difference. So the first thing we're going to do is we want to add a light into our scene. Under the rendering tab, there's all these different lights with icons. We'll just go to, usually when I'm starting out or learning, you want to go to create lights. You can see the different types. It'll actually list what they're called, and then you can have their options next to them. But ambient, directional point, spot, area, and volume. We'll do a couple of these. So an ambient light fills up any space. Directional light comes from a specific side. Let's start with a directional light. So choose a directional light, and you'll get this icon with these little arrows on it. And we want to set up our viewport so we can actually see the lighting. Before I showed you the 1, 2, and 3 keys, where if I have any objects selected, 1 is its raw mesh, 2 shows the cage with the smooth, and then 3 shows the actual smoothed element. And that's something we'll do with this cube. That's why we wanted some specific stuff on here, is once we start to render. In fact, do that now. Actually, turn your cube into a smoothed cube. If it didn't have 10 sides like that, or 10 levels of detail on this, add that now. Select the cube, go to the attribute editor, go to the polycube one, and make sure, the little one, not the big one, that it's got 10 levels of subdivision on each side. So that when we smooth it, it's got these nice rounded corners. And the reason we have that is as we look at these lighting effects and these materials and rendering effects, we're going to see a lot more interesting stuff with these rounded corners than we would if they were flat. And we'll compare, go back and forth. Whoa, I smoothed my big cube. Select just the small cube. Now I'm inside the room, so I can't like click away from anything to deselect, but I can inside the outliner. I can click in this area in the outliner, click away, and then click on my cube and hit 3 away. All right. So now the next buttons, 4, 5, 6, and 7 do stuff also. So 1, 2, and 3 are all based on smoothing. If you press the 4 button, that will show wireframe display of your scene. If you press the 5 button, it will show the shaded view of your scene with no lights, or with default light. If you press the 6 button, it will actually show texture maps, which we don't have any. We don't see anything yet. But if you press the 7 button, then it shows the actual lighting in the scene. All right, so take a moment and play with those and see really 4, 5, and 7 are only those ones that are going to do something right now. But again, 4 shows you wireframe, 5 shows you shaded view, and then 7 will show you shaded view with lighting. 6 turns on your textures. So typically, you'll work with all of these things on, and you can see the effects. So this directional light, I can grab it and I can move it or rotate it around. Now it doesn't matter where it is. In fact, let me move it around the scene. See, that light isn't changing as I'm moving it around the scene because a directional light is just infinity when it comes to the default light. And if I rotate it, that's what matters. In fact, I'm going to go back to a 2-up view. I'm going to rotate it from the top view. And go ahead and try rotating your directional light and see in the viewport how it automatically updates, which is pretty cool. And then at any point, you can press that render button again. Whoops, you have to have the right viewport selected or it will just render top view. And you can see that directional light happening there. See, the directional light is what you would use for like sunlight or something like that, like an outdoor scene, where it's just constant from one position. Now, when you use these traditional lights, there's typically many lights in the same scene. But one thing I want you to be aware of is when you hit render, it happens pretty much instantaneously, right? Like there's really no render time here. Just may take a second. So it does actually say at the bottom, render time, 1 second, poof, shows up. All right, let's take a quick look at a couple of the other lights. Again, if I delete this light, so when I deleted that light, if I'm on the 7 key, it's showing me that there is no light in the scene. Everything's looking black. But if I hit render, with a software render, it kicks in this default light that comes on. As soon as I add another light, that goes away and it uses just that light. So if I go to create, instead of a directional light, I'll do an ambient light. And this is more of a light, this looks like that fills up everything in every direction. All right, so if I render that, you can see what that looks like. Notice that it's definitely different in the viewport. So the lighting isn't always 100% accurate in the viewport. You're always going to want to render and see what it is. So very flat though, very flat. I can barely see the corners in the room because it's so flat. It's just sitting right in the middle. And then we've got delete that, create lights, a point light. This is like a light bulb. All right, so you can see in the scene, open it up, you can see that it's illuminating that. Let's go and render it. And it's not really showing on the edges in the scene, which is interesting. But this is also kind of radiating outwards. And then there's some other types of lights. I'm not going to create all of them. Spotlight, you can actually point with a direction, and there's some cool manipulators on the spotlight to be able to adjust like the penumbra and the different like cones on each side of the light. There's a lot of options inside of that spotlight, which is really cool. But here's what I want to do real quickly just to set up a basic scene is typically when you're using default lights like this. Whoops, I just moved my camera. I shouldn't have done that. I'm going to hit that bracket key to get it back. I'm going to go back here so I have these other scenes to work through. Typically what you'd set up is called 3-point lighting. That's the most basic way of a traditional 3D lighting setup, where you typically use 3 different lights. You'll use kind of a backlight kind of a full fill light that fills the whole scene, and then you'll use like a light to show some detail, right? So if I were to, let's say, start off, now this part I'm going to want you guys to kind of do, I'm going to want you to create a quick little 3-point lighting system. And what we'll do is we'll create an ambient light that will kind of stick behind everything, that will give it a little bit of a backlight and just kind of fill everything in. Then we'll give it a directional light to give it a main light that's coming from a specific side. And then maybe we'll stick a spotlight or a point light in a different position just to have 3 different lights kind of bouncing around on things. So I'm going to start by creating an ambient light that instead of in the middle, now I have my attribute editor open, and I know for sure I don't want my ambient light, as I check my renderer, to be, it's rendering the perspective view right now, which is actually fine for me to see what's happening outside the cube. Typically I want to right click in this viewport and click it to see this. All right, so now it took 2 seconds to render. But I know I don't want this bright. I know the ambient light in my 3-point lighting system is going to be something very, very limited. So I'm going to select that little light icon. I'm going to bring its intensity down to 0.5. Like maybe I'll even bring it down to like 0.3. And then I'm going to move this into the back of my cube. Make sure I don't go out of it, which I did. And that's where the orthogonal views can help. So I'm in the back, the top. Maybe I'll move it over into this corner a little bit. I want this way. Oh, my phone's ringing. Oh. All right, so that's good for my ambient view. I'm going to check this, render it. Got a very dim back light, right? So now I want to add in a directional light. I shouldn't just add it from there. Make sure this is what I think it is. Yeah, it's a directional light. All right, so let's click that, same with the directional light. And it's coming from the direct side. I'm going to just rotate this around. You guys can do this with me at the same time. Just make an ambient light, bring it down to like an intensity of 0.3, or at least down some. It doesn't have to be exactly what I do. Just dial down the intensity a bit. Then create a directional light and rotate it around a bit. So it's just coming from an interesting angle. I'm going to have mine coming kind of from the front top angle a little bit. And again, you don't have to move the directional light. You can if you want to get it out of the way and not in the middle. In fact, I'm going to help illustrate where it's coming from. But notice the lighting doesn't actually change at all when you do that. So I added that second light in from an interesting angle. Check my rendering. And already that makes a huge difference. Then the default look is being able to have, you know, just a little more depth. Each of these different 4 walls that I'm seeing are a different color, getting different amounts of light. I'm seeing some shadow, well, not actual shadows, but some shadowed area of the objects over on the side here. It's just a lot more interesting than the flatness when we just have a single light or a default light. So now then finally, I'm going to add a point light, which is more of the light bulb shape. And I'm going to move that kind of right over, kind of in between my sphere and my torus, so that it's really going to get some light bouncing off of those two. Stick it in there. Okay, try and render my scene. And that's a little bright and washed out now. So I think I'm actually going to dial down my spotlight a little bit, or my point light a little bit. And select it, maybe bring its intensity down to like, I don't know, 0.6. See how that does. That's better. Not quite as washed out, but I can see a little bit of that light coming through in these 2 spots. And this is really going to change as we start turning on features and adding materials and shadows and things like this. But we want to start with the basics and build up to it. All right, so that is, I'm going to save my file, and that is a basic 3-point light setup. That's like, you know, anything less than that, and you should have more lights in your scene. Now, when we get to using photorealistic lights with Arnold, that's one of the advantages. It's a very quick setup. You can just have one light and have it bouncing all over the scene and create amazing effects. But yeah, the rendering time is where it sticks you. So I want to start with this. But I'll give you guys a minute. Another thing is actually I'm going to tint my lights ever so slightly. That when we're working with just traditional non-physical lights is the term for them. They default at a real bright white, at the brightest white, but there's really no such thing as white light like that. So I'll typically dial them back into the yellow a tiny bit. So I'm going to grab each one individually. I'm going to grab the ambient color, And I'll just put this in yellow and just dial it in ever so slightly, just so it has a slight yellow tint. Now you could, if you wanted, you know, go nuts with it. So for example, if I take my directional light and just turn it blue, you know, you can actually see that update in the viewport. If I were to render, sure enough, now I've got some blue and yellow lights and stuff going on. So you can definitely have colored lights and go nuts with it. But when you're looking for photorealism, typically having something just ever so slightly in the yellowed range. All right, so I tinted them ever so slightly and rendered it. All right, so take a moment. If you don't have it already set up, get yourself a nice little 3-point lighting set up. Give it some very subtle yellow colors, and then we're going to start adding some more detail to this in a moment. So save your scene. You know, have you ever seen any kind of photo shoot, photographers? It's the same thing in 3D. There's just all kinds of ways to make lights. Now this is traditional, again, non-physical lights that aren't actually calculating bouncing off a surface and everything. I'm going to show you as far as these go. We're going to pay particular attention to the render time, because right now I'm sitting at 1 second. All right, so the next thing we want to do is let's go ahead and cast some shadows. Again, I'm going to show you the different levels of realism before materials, and then you'll see how materials adds to it. I believe that going in this from the bottom up kind of layered approach helps you understand how to get the realistic, you know, look and how it affects rendering time the best. So we have to actually turn on shadows for any individual light with these traditional lights, because a lot of times you don't want every single light to cast shadows. We don't necessarily want the ambient light to do anything, but let's just try it. Let's initially start with our directional light. So select your directional light and have the attribute editor open. And your directional light is definitely going to cast some serious shadows because it's coming from one direction. So notice in the attribute editor, there's a shadows drop down, all right? And right now, a lot of it is grayed out. And I want you to select this use depth map shadows. And all of a sudden, all that opens up. And notice nothing changes in your viewport. But go ahead, and once you've selected use depth map shadows, your directional light, render your scene, and all of a sudden you'll see some shadows going on. So this just increased its interestingness like tenfold by having these shadows turned on. You can see that I'm getting this shadow from like the box coming through, which is interesting, from like the opening. Interesting what's going on here. So now I'm going to try, now notice also the shadows are real rough. I'll show you how to deal with that in a minute, but again, it's rendering time. I'm going to try each of my individual lights real quickly and see what their shadows look like, and then maybe turn them on all together. I'm going to turn off of that, re-render, shadows are gone. Now I'll choose my point light, add some depth map shadows, re-render it. Okay, so that's interesting. That's got like a giant shadow of the box behind it. It's got a giant shadow of the torus down there. And now I'll take a quick look at doing that for my other light. So if I turn off the shadows for the point light, and I turn on shadows for just my ambient light, well, I guess the ambient light doesn't have that option until we get into ray tracing, which we're going to do next. So maybe I'll turn it on now for both the point light and the directional light and see if it looks a little too chaotic, or if that's what I'd want. Okay, it's pretty chaotic with these giant shadows going on down here. So I think I'm actually going to turn shadows off of the point light. That's not really giving me the desired effect that I want. So I can turn those off. And I think I'm just going to stick for now with the directional light. And you could play around with moving the directional light around and seeing how that gives you different shadows. But I'm happy with this kind of shadow mark I have on the front here, and this nice shape I'm getting across the torus. A little just soft, you know, softness on the cube here. So first of all, notice that the shadows look crappy, right? Like they're super jaggedy. And that's because of the resolution. I want to dial this up. So instead of 512, let's go to 1024, and now I'll re-render that window. And now the shadows are much smoother, but it took 2 seconds instead of 1 second, right? In fact, now I want these to look really smooth. I'm going to bring this resolution up to 2048, and I'm going to render that again. And now it took 3 seconds, but now my shadows are like nice and crisp and clean, and it's a lot smoother. So that's just a quick little thing, and this is a game that we'll play as we're rendering things in Maya is we will constantly dial down quality to test things out, and then we'll dial it back up when we're ready to like render out a final scene or a final image. That's just part of the game with 3D. So put it back to 512, no big deal. All right, now that is very, very basic. So we're able to light a scene. We're able to get some depth map shadows. In fact, I'm gonna leave my resolution at 1024, these shadows, so they don't look totally crappy, but it still only takes me, I guess it's back to 3 seconds. It's only taking me about 3 seconds, which isn't too bad to render. I'm gonna save my scene. So this little icon up here, right next to the render settings, is the hypershade. And this is where we can get into a lot of very intense shading. The term shading in Maya represents materials and textures. Materials is kind of what it's made out of. Textures is when you get into taking like images and wrapping it around it, making it look photorealistic and stuff. But the term shading in Maya is we create these shaders, different materials, different shaders. There's tons of stuff in here you can get into, different ways of looking at it. I want to look at it on a teapot versus a shader ball. I'll get into some of the stuff in here, but for right now, there's more there than we need to deal with. Just see that it's showing the default materials that show up in here. This is our materials list. This one shouldn't be in there. I was monkeying around earlier. Let me delete that. Maybe it comes standard in 2020 now. I don't know. But anyway, this Lambert 1 material, this is the one that we're initially working with. I'm going to close that. We'll come back to that. I just wanted to point that out so when we come back to it, it'll make a little more sense. But we can get to the materials through the attribute editor like this. And what we want to do is we want to create a new material for each object. All right. And the simple way to do that is to select it in the scene and right click it and go to the bottom and click assign new material. See, there's also assign favorite, assign existing, there's all kinds of stuff, but click assign new material. And that should open this assign new material dialog box. And you'll see a whole bunch of materials down here with a bunch of things. And we'll want to select just, want Arnold materials, we want just Maya. Okay, so click on just Maya under favorites. You'll see the standard surface, blend, Lambert, Phong, ramp shader, all this different stuff. The standard surface is new in 2020. I'm going to skip that one for right now because we're going to use that when we use Arnold. This must be Maya's way of trying to do Arnold-y type stuff with their default renderer. But typically the three main ones are blend, Lambert, and Phong as far as just basic materials. And these are all named after like scientists that came up with these algorithms and stuff. That's why they're funny names. They're usually people. But typically a Lambert material is more of a matte material. Blend is like a little shinier, like metal, and then Phong would be like super shiny, like something glass that you would make semi-transparent or something like that. So we're going to make a couple of different basic materials and see how it affects with the basic renderer here. So let's start with adding a Lambert material to the room. All right, and what it does when you do that, so again, all I did is I right-click on the object and go to assign new material, and then I chose Lambert from the list, and I filtered that list by clicking the word Maya up there at the top. And it automatically creates this material called Lambert 2, because Lambert 1 is the default, and I'm going to rename this to be Room Matte. All right, this camel case is very common with both programmers and 3D to name things in camel case, where it starts off lowercase, and every time you change a word, you cap it and don't have spaces or anything. So this is the room material. And now I can change a couple of these basic attributes. I'm going to change the color. Instead of this gray color, I'm actually going to make it a little more white. And maybe I'll give it an ever so subtle, I'll keep it white. I'm not going to go 100% white. I'm going to dial it back and go a little more than the gray was. All right, that's going to be relatively basic. Okay, so I set that material up. Probably won't see any difference in a render. Actually, I did. It brightened it up quite a bit. That's nice. Okay, brightened it up quite a bit. All right, so we got a Lambert material there. Now I want to add, let's add a new material to the cube. I'm going to right-click the cube, choose Assign New Material, and this time, again, I'll click that top Maya under Favorites. Will give us a filtered list that shows us more of just these traditional materials. I'm going to choose Blend this time, which is a little bit shinier and just has different material attributes. You know, we'll play with transparency in a moment. There's tons of stuff in here. There's just countless settings. We're just going to go through the real basics here because we're going to end up using an Arnold shader for everything. But again, I want to show you the progression because I think it's very, very important to understand what you can get away with very, very short rendering times versus just using the biggest and best and most awesome looking, but can take rendering times forever. So when I added this blend material to it, if I deselect, I can already see, especially if I go to my one-up view, even without rendering, I can see some shininess got added to this cube here. Something very interesting to note. See how nice this little shininess looks on the rounded cube? Some of you may have noticed that when you render, the Maya software renderer does not recognize smoothing. That is something that Arnold does recognize and makes a huge difference, as we will see. All right, so that smoothing that I put on that is not affected by the software renderer. It's really important to understand. But again, why am I showing you this renderer? Because first of all, just the basics of setting up traditional lighting, 3-point lighting and traditional rendering, but the speed is so much faster. There's many situations where you may just want to use the software renderer to get something out. All right, I'm going to change the color of this a little bit. I can go back to select it and I can see my blend 1 material. In fact, I'm going to rename this and call this cube matte. All right, and now maybe I'll change the color. Make this kind of a burnt orange color. All right, updates in the viewport. I can check my render. It's this burnt orange color, whatever. And now let's do the same thing to these two. I'm going to create and assign a new material to the sphere. And maybe I'll make the sphere a Fong, which is meant to be very, very shiny. You can see the specular highlights show up on it right away. Maybe I'll change its color to more blue. I'm going to pull the grayness out of this color. I didn't realize I was doing that a little bit. All right, so I've got a Fong. I can check that render. And I can see these specular highlights show up on here. And then finally, I'm going to do it to the torus. Select the torus. Whoops, I totally got in weird modes. Object mode, right click it, assign new material. And this time I'll do a Fong E, which is a variation. It's still shiny, but it's got more like crosshatches in it, like shiny metal might be. So change that Fong E, and maybe I'll set this color a little more deep magenta there. All right, so I'm going to hit say, and I'm also going to name that material. Instead of Fong E1, I'm going to name it Torus Matte. I'm going to name my Fong 1 Sphere Matte. Now notice that materials, as we create them and name them, notice that they do not show up in the outliner. Okay, we'll open the hypergraph back up in a moment, but these materials do not show up in the outline. All right. So I've given them all names, so I can click on each of my 4 objects now. I can click on the room, and I can see a room matte material, which is a Lambert. I can click on my cube, I can see a cube matte material, which is a blend. I can click on my sphere, I can see a sphere matte material, which is a Fong. I can click on my torus and see a torus matte material, which is a Fong E. All right, now I'm gonna go ahead and save my scene. I'm gonna render, and now I'm taking about 2 seconds, and you can see that, all right, basics, we started with clay. We were able to now light things with this nice 3-point lighting. We got some backlighting, some directional lighting, and a little point light here, which is giving us these nice specular highlights. If we took all the lights away, even though we have colors, this will still look very flat and bland. And we're able to add different materials to have different levels of, shininess and everything like that. So now let me show you a little transparency, and then we're gonna get real interesting. Let's select the sphere, and in its materials, in the attribute editor, you can see directly underneath colors, transparency. It's just a slider. So I'm going to slide that down to about half transparent. Hit save, and check my render, and you can kind of see it. You can see that you can see through it. You can see the wall line there, but there's not really anything interesting to it. It still looks pretty flat, right? Like there's no light bouncing around from object to object, and that's going to be the next step. Make sure that you have a material on each object. change the colors a little bit and make sure you have some, try the Lambert on the walls, which keeps it nice and flat, and then have a blend, a Phong, and a Phong E on these separate things. Give them a little color, give them names, save your scene, and then we're going to take the next step of ray tracing in a moment and see this really kind of pop into life. Again, we're slowly building our complexity and our quality up from the ground up, starting with the most basic. By the end of the day, we'll be able to have this room looking very photorealistic, and you'll see the reality of render times very quickly, which will get very real and important when we start to render out animation sequences. All right, so now let's move on to the last step in actual software rendering. All right, first off, you've got to have a model to see everything. Second, you've got to have some lights. 3-point lighting is the basic old school 3D method of at least getting some depth in your scene so it doesn't look completely flat. Any real professional lighting setup may have 100 different lights in the room bouncing, doing all kinds of things, but 3-point lighting is just a basic, easy setup. See the differences. We've got to turn on our shadows individually, and now we've added some materials, which gives us some different levels of specular highlight, even added some transparency. What really pulls this all together with the software renderer is what's called ray tracing. What ray tracing does is it's the beginning of a physical-based lighting system where it actually calculates, and the rendering times will go up quite a bit. It actually calculates rays of light, which is why it's called ray tracing, from their source to a certain threshold that we'll set up. We'll use the default at first. We can dial it up or down. It will calculate those rays actually bouncing around the scene, and it'll do very interesting things like add caustics inside of transparency. It will reflect objects onto other objects, like their color, all kinds of interesting things. So let's go ahead and find a way to turn that. So I'm going to shut that off, and let's go open up I'm going to deselect everything, open up the render settings dialog box again. And inside of the render settings dialog box with this Maya software renderer, there's 2 tabs. There's a common tab and a Maya software tab. We'll deal with the common tab later. The common tab is the same in any of the renderers for the most part. If I switch between them, there's small differences, but for the most part, they're all basically, this is how you deal with the file output. So this is where we would tell it, how we want our files to be named, what file type they're going to be named, what frame range if we're doing an animation, what cameras we're rendering, all that stuff. In fact, I'll set that to camera 1 from my perspective. A bunch of different options in here, the actual size of the image. But for right now, we want to go into the Maya software tab. And this Maya software tab has these quality settings: custom, preview, intermediate, blah, 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 anti-aliasing. The defaults are set to be lightning fast and crappy quality, okay? Under the quality, instead of custom, let's just click on production quality. And what that does is that turns on a whole bunch of these things. In fact, actually, go back to preview quality for a moment. And if you open up ray tracing quality, you can see that ray tracing isn't even on, all right? We would have to manually turn ray tracing. Now, we're just going to use these presets because we don't need to get into the depths of how many of what these numbers and what they mean. We could just turn on ray tracing and see something real basic. In fact, you know what? Let's do that first. We'll try it this way first. So leave it on preview quality and then just turn on ray tracing right here. So just go down to ray tracing quality, click that box, leave the reflections, refractions, and shadows as they are, and then hit close. So all we did is go in, Maya software, go down to the ray tracing quality drop down and turn on ray tracing. Now, one other step we want to make before we render is ray tracing creates ray traced shadows, which are different than depth map shadows. If I have them both on, it's probably going to be chaos. So maybe I'll just render for a second, and I'm seeing a whole bunch of stuff going on. But one thing I want to do is I definitely want to turn off my depth map shadows, because the ray tracing will create shadows itself, and it will create better shadows than the depth map ones will. It'll take longer as we get into it, but it'll create better ones. So I'm going to go back into my directional light, uncheck use depth map shadows, and then the ray tracing should create shadows of its own. I say should, it's not. Maybe that's because it's not on production quality. Oh, no, I'm sorry. You need to manually turn on use ray trace shadows. So even though we have ray tracing turned on, you can do ray tracing with just depth map shadows, which we did at first. And you can see the difference is all of a sudden, it looks a little chaotic, but we've got a whole bunch of like reflections and stuff going on in our funny materials here. Like you can see the cube and the sphere being reflected on the torus. You know, everything's kind of being reflected onto each other. It doesn't look great, it looks a little chaotic, but you can see the effect that's starting to happen when we turn ray tracing on. Now, the depth map shadows are pretty good. They're okay, but ray tracing shadows are better. They should be more photorealistic and actually, you know, physically correct. So even though we turn ray tracing, it doesn't automatically create ray tracing shadows. We have to go in and manually on whichever lights we wanted to use, turn off depth map shadows, turn on use ray tracing shadows. You can just leave the defaults. And now when I refresh my render, it will look a ton different with this, but they are indeed now using ray traced shadows instead. I can see actually this little line here is a little bit different, but now I'm going to change this to the production quality view. In fact, actually, I'm going to save the image. In the render view here like this, there's these little icons up here for keep image and remove image. This is useful for you to be able to compare between renders without actually having to save an image out to your disk and look at it that way. So what you can do is just click Save Image, and now it brings up this little scroll bar. And next time we render, we should be able to compare the two. So now I'm going to go in and open up my render settings. And I'm going to set the quality, but under the main quality one where it says preview, I'm going to go all the way up to production. Now, we don't need 3D motion blur production or contrast sensitive production. We'll just go to production quality, and that's going to ramp up a lot of these features. I believe, let me check the difference in ray tracing. So when I have preview quality, you can see ray tracing is 1, 6, and 2 for reflections, refractions, and shadows. And this is a game of dialing up and down for quality versus render time. And right now that render time took 2 seconds. If I go up to production quality, I can look at the ray tracing and see everything's been ramped up to 10. I don't have motion blur. We don't have any animation. But anyway, I'll try this out, render my view. And I see this blockiness happening for a moment. The render took 6 seconds. I can compare between my two by sliding this little thing. In fact, I'll go back to the 6 seconds and I'll hit save image. So now I've got 3 of them I can slide between, the current render and then the last 2 saved images. As I toggle between the production quality and the preview quality, you can see it mostly on the edges, on the anti-aliasing. So with the preview, you can see the jagged edges around all the reflections and refractions. And then when you have the production one, you can see that it's a little bit more smooth, all right? So this is kind of interesting. If we wanted to see things get real crazy, we could, for example, change around our materials. It's an interesting view, but it's not great. We're seeing a bunch of reflections and refractions in these things, but how about we change our materials around and add one to the actual cube? Let's right-click on the cube and choose Assign Existing Material. And you'll see the list of all the existing materials. And I'm going to add the torus material to the cube. And then I'll do the same thing on the torus. I'm going to assign existing materials. I'm going to add the room material to that. All right. And then I'm actually even going to move my sphere. Well, I'm tempted to move my sphere kind of in front of this a little bit. I think I'm going to. I'm going to move my sphere so I can see it overlap that cube a little bit, just to see what that does. All right. Oh, I accidentally set it back on the room because I had them both selected. So I have to select the room only, go back, assign existing material, torus mat. So now this torus mat should have some reflectivity to it because it's a blend material. So now if I render my scene, basically I should see things bouncing around on the walls quite a bit more. And this blockiness, this is part of rendering, that's it doing its job. And now we've got a bit more of an interesting scene, all right? So now I'm going to save this image. Now I can compare, keep dragging along this and compare between these images. But between this one and this one, this is a lot more interesting scene than this one is, because really I can see so much more going on around in the room. I can see these reflections in the back of it getting reflected back. So there's a lot going on here, all right? But this is really the limits of the software renderer. Notice that that took 10 seconds, all right? We are at production still, looks pretty good. You could move around your camera, you could move around the lights, you could move around the objects, you could change transparencies. In fact, let's do that. Let's make this sphere 100%. Go back to the sphere material. I'll make this 100% opaque, but then I'll make the cube transparent. And I'll go like quite a bit transparent. Let's see what that looks like. Oops, did something to my room. Selected it in a weird way. All right, so I think I want to dial up that cube a little more, or maybe I will, here as a final view, don't really like that. I'm going to dial the cube back up to 100% transparency. I'm going to bring this torus up, kind of stick it in there, make it a little bit transparent. See what that looks like as these things are all over each other, bouncing around on each other. Well, that blew it up as far as time. Okay, all right. So anyway, I'm going to go back to, but you can see that, you know, not looking through the circle anymore. I bet if I kind of turn the view around. Okay, so anyway, I'm gonna undo back to, just showing you some different effects. I'm gonna undo back to where my materials were on the correct objects. I've got my base and get back to that. There we go. Okay. I'm gonna hit save. I'm gonna check my render one more time. And I just wanted to show you that, you know, based on these materials and what's in the room and this and that, like we can definitely get a lot more interesting effects just by changing around the angle of the light, the angle of the camera, the different materials on different objects, having those different Lambert on something you don't want, things reflecting off of, falling in or different levels of it, and turning on those shadows and using ray tracing really gives you like the full gamut of being able to create these different effects, all right? Now, this is very, very fast. Rendering this scene in 10 seconds, even this one that was the most complex, that was bouncing things off the environment a little bit more. You can see some complex shadows. And again, I only turn the shadows on for one light. You can turn them on for multiple lights and get even more complex. The more transparency, you know, you can play with different variables and values inside of these materials. You know, you can get across different things. But this is the basics to get a basic 3D look with some interesting shadows and reflections and refractions with very, very fast render times.